Let me start this up right here. Make sure I'm good. All right, I'm good. I'm good. I'm good. All right, so let's look at what we're getting into today. All right. It's going to be a kind of an easy day today. Not We're not going as hard. Yeah, yeah. I mean, if you look at your homework, I mean, low key, you probably know how to do your homework before today's lesson. Well, oh, you on the second homework? Good, good, good. Remember that y'all got tutoring online too. So if you can't make it in, you can always go on. Not during the summer. Not during the summer. Yeah. What I was thinking is over the weekend if you needed help, maybe little AI could help. I again I really love my Microsoft Copilot. Yeah. Yeah. I mean, if you got the ChatGPT, then use it. Like I'm about. Oh, I see. Yeah. It's just that we got the free Copilot, so that's why I like to promote that a little bit. Yeah. Yeah. But yeah, but ChatGPT does that too. Yeah. But you kind of gotta like talk to it, like tell it to do that. Yeah. I mean, how can I say this now? If you came to me and you was like, "Yo, help me," I would know how to do it, right? Like I would know how to break it down step by step and all that, right? When you talk to it, it doesn't know that. Like to break it down step by step, to ask you leading questions so that you can get to the answer, stuff like that. It does? Yeah, yeah. I mean, ChatGPT does that. It asks you leading questions and all that. Yeah. All right. All right. Yeah. Yeah. I mean, I've never used it, but yeah. That's what I'm trying to avoid, y'all having to pay for it, you know? Yeah, yeah. But you could do that in Copilot too. You could do the picture with the phone and all of that, you know? Yeah. I'm gonna tell you an issue that I encountered with Copilot, right? Before we begin, right? So this is an English issue. It's not really a math issue. So you have to kind of like give it the information. You got to like teach it a little bit before you ask it a question, because it'll hallucinate like nobody's business, right? Like it will make up a story. So my issue is giving Copilot the information and then asking it to do something with the information, right? So there's a limit on how many characters you could type to Copilot. I mean, it's a big limit, but it's a limit. So long story short, I found out that in Copilot you can actually give it a PDF, like all like a book or something, and then ask it the questions right after. I didn't know that. Like for me, that was a game changer learning that. Because what I was doing before was I was copy and pasting pages into it, and the thing is that it takes so long, you know. Um, so here's the real reason why, like what the application I was doing, right? I wanted Copilot to generate practice questions for a class that I tutor, right? Um, There's a certain number of pages that the students have to read for their test, right? So I wanted to take those pages and make up a quiz, like a 20 question quiz, whatever, for them to practice yeah, yeah, yeah. But the question is, how do I give it them 20 pages? You know? So now I know how to just give it the book and be like, all right, listen, from page 182 to 209, right? Make a quiz on those pages, 20 questions, 10 multiple choice, 10 fill in the blank, whatever, boom, right? And then after it makes it, like, give me the answers to the joint, 'cause I don't even know how to do it. you know? Yeah. And it does a great job, the co-pilot. Now, with ChatGPT, can I give it a book? I gotta pay to give it a book. So what I'm yeah. Because what I'm saying is, like, picture we in chemistry class and we got a test on chapter one, right? Like, chapter one is not 3 pages. That's like 18 pages, So to give it all that and then say, all right, give me a quiz so I can study, like, that's making it a little bit harder now, you know. I don't know, I'm trying to avoid the fee. How you doing? Yeah, yeah. All right, let's look at what we're getting into today. All right. Huh? Oh yeah, yeah. I don't know. It just came in and that was it. I blame the rain. I blame the rain. You know. I was on online earlier. Google clearly said 9 p.m. So I'm like, I don't know how I'm gonna make it out of here, but at 5:30 it's coming down. I'm like, yo, for real. You heard 6 or 7? Yo, Google be lying to me. I heard a storm too. I heard about a storm too. Uh, yeah. All I know is, like, to me it's a blessing though, because in my opinion, July 4th is always the hottest day of the year. So, like if we getting rain today, I feel like we getting blessed tomorrow. You know? Yeah, yeah, yeah. Um, by the way, y'all, on Saturday they got the Bronx night market. I don't know if anybody wants to go through. It's on Fordham. You know? Yeah, yeah. It started already. It's every last Friday, but this is a random Saturday going up. Yeah. Like, try it out though, man. Wait, there's a Queens night market. Yeah, 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 yeah. And there's a Harlem one too. The Harlem is Uptown Night Market. Yeah, 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 yeah. It's really good. Yeah, 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 yeah. A matter of fact, this summer is the last of it. Like, they discontinuing it after this summer. Um, October. Yeah, so it's every last Friday, excuse me, last Saturday of the month. They have it. Yeah, yeah, yeah. But this particular Saturday is like a additional Saturday. It's random. Like, the borough president is doing something, so that's why that's happening. But yeah, if anybody wants to go, I'm thinking about showing up myself. Yeah. All right, let's take a look at this real quick, right? So a reversible heat pump is a climate control system that is an air conditioner and a heater in a single device. Operated in one direction, it pumps heat out of the house to provide cooling. Operating in reverse, it pumps heat into the building from the outside, even in cool weather, to provide heating. As a heater, a heat pump is several times more efficient than conventional electrical resistance heating. In some physical machines, we can run in two directions, right? We might ask whether some of the function machines we have been studying can also run backwards, right? So figure one provides a visual representation of the question. In this section, we will consider the reverse nature of functions, right? So we about to flip it and reverse it, right? Is Eric? Yeah. Damn, I could tell y'all young, man. Y'all don't even know what I'm talking about. Jeez. Y'all is young. OMG. I mean, are y'all Teletubbies? Yeah, yeah, y'all Teletubbies. Because I'm Barney. I don't know. Yeah, yeah, I'm talking old. I'm Barney over here. Yeah. I mean, but I'm not that old. Like I'm not Michael Jackson. I'm like Janet Jackson. You know, like yeah, yeah. I got limitations. So verifying that two functions are inverse functions, right? Betty is traveling to Milan for a fashion show and wants to know what the temperature will be. Hot. She is not familiar with the Celsius scale. To get an idea of how temperature measurements are related, Betty wants to convert 75 degrees Fahrenheit to degrees Celsius using the formula. So here's our formula. Celsius is equal to 5 over 9 times the Fahrenheit minus 32, right? So, and all we do is we substitute the 75 for the F, right? And then boom, 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 we get the degrees Celsius, which is 24 degrees Celsius. All right. We all know how to do this. Very simple. That's not that complicated. All right. So now, 1 minute, got a little pop up. All right. So knowing that a comfortable 75 degrees Fahrenheit is about 24 degrees Celsius, Betty gets to the week's weather forecast from the figure, right? From Milan, and wants to convert all the temperatures to degrees Fahrenheit. So here we go. We got Monday, a little bit of rain. We got 26 degrees Celsius in the day, 19 in the night. Tuesday, 29, etc. You get the idea, right? I look at this all the time. Y'all ever notice over time, like we don't just get like 4 day forecasts no more. We be getting like some 7 and 8 day forecasts now. You know, it's kind of fire. Yeah, I know. Yeah, 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 yeah. I got caught in it. I was shocked. Yeah, yeah, yeah. When I was coming over, I'm like, because Google clearly said, I'm telling you, man, it really said 6 o'clock. I mean, excuse me, 9 o'clock. That's when they said it was going to start, and it's going to finish at 10. You know. All right. Anyway, at first, Betty considers using a formula she had already found to compute the conversions. After all, she knows her algebra, right? She can easily solve the equation for F after substituting a value for Celsius, right? For example, to convert 26 degrees Celsius, she could write 26 is equal to 5 over 9 times the Fahrenheit minus 32, right? Then you just solve for it, divide by the coefficient on both sides, add the 32, that's it. Easy, right? 79 degrees, right? But after considering this option for a moment, however, she realizes that solving the equation for each of the temperatures will be awfully tedious, right? She realized that since evaluation is easier than solving, it would be much more convenient to have a different formula, one that takes Celsius temperature and outputs the Fahrenheit temperature. All right. So the formula for which Betty is searching corresponds to the idea of an inverse function, right? Which is a function for which the input of the original function becomes the output of the inverse function, and the output of the original function becomes the input of the inverse function, right? So given a function f of x, we represent its inverse as f inverse of x, which is read as f inverse of x. The raised -1 is part of the notation, right? It is not an exponent, all right? So f inverse is not f to the -1 power, right? It's a notation, right? So it does not imply power to the -1. So in other words, f inverse of x does not mean 1 over f of x. Just so we're clear, right? because 1 over f of x is the reciprocal of f and not the inverse. Clear on that? That makes sense? It's not f inverse. Right. It's not raising it to the -1 power.
That's right.
Right. It's a name. Yeah. F inverse is a name. Yes. Think of it like that. It's almost like the opposite. It's like we're gonna get into what it is, but it's like a reverse equation. All right. That's not it. I'm all I'm saying is that the notation F inverse is a name, right? It's not F to the -1 power. That's all I'm saying. Right there. Yeah. I got you. I got you.
I don't understand this.
Yeah. They big time philosophers, so they know what they're doing. Yeah. Yeah. All right. So the exponent-like notation comes from an analogy between the function composition and multiplication. So just as A inverse times A is equal to 1, right? 1 is an identity element for multiplication for any non-zero number A. So F inverse composed with F equals the identity function. All right. So F inverse composed with F of X is equal to F inverse of F of X, right? Or F inverse of Y, which is going to be equal to X, right? This is an important formula. We're going to be using that in the future, all right? That's how we prove, right, that two functions are inverses of one another, all right? So this holds for all x in the domain of f. Informally, this means that inverse functions undo each other. All right? Inverse functions undo each other. However, just as 0 does not have a reciprocal, some functions do not have inverses. All right? So given a function f of x, we can verify some other functions g of x is the inverse of f of x by checking if both g of f of x, right, is equal to x and f of g of x is equal to x are true. For example, let's say that I have y equals 4x and I have y equals 1 over 4x, right? And I want to know, are they inverses of one another? So how do I check that? I do f inverse of f of x, right? Where I'm gonna do the inverse of the 4x, and then I'm doing a composition. I'm plugging in one function into the other, right? When I'm done simplifying doing the math, if I get out the letter x as my answer, just plain old x by itself, it's an inverse, right? But to verify it, I do it in reverse as well, right? So take one function, plug into the other, flip it. Take the other function, plug it into the other. If they both come out to x, they're inverses, period. All right. So that's what that's saying right here. Right? And we all know how to do compositions. We did that already. A few coordinate pairs from the graph of the function y equals 4x would be, for example, -2, -8, 0, 0, and 2, 8. A few coordinate pairs from the graph of the function y equals 1/4 x are -8, -2, 0, 0, and 8, 2. If we interchange the input and output of each coordinate pair of the function, the interchanged coordinate pairs would appear on the graph on the inverse function. All right. When I say interchange, that's like a $500 word for the swap. All right. So real quick, let's talk about inverse function real quick. So this part is really important right here, right? For any one-to-one function one-to-one function. F of x is equal to y. A function's inverse, f inverse of x, is an inverse of f if the inverse of y is equal to x. This can also be written as f inverse of f of x is equal to x. For all x in the domain of f, it also follows that f of f inverse of x, right, is equal to x for all x in the domain of f inverse if f inverse is an inverse of f. All right. So the notation f inverse is read as f inverse. Like any other function, we can use any variable name as the input for f inverse. So we will often write f inverse of x, which is read as f inverse of x. Keep in mind that f inverse of x does not equal 1 over f of x. This is what I'm saying before. All right. It's not a power, it's a name. All right. And also, not all functions have inverses, just so we're clear. All right.
I was trying to figure it out. Figure it out.
Yeah.
I can ask myself.
Got
So
you.
there, but I don't know.
Mm-hmm.
So x equals like 2x.
Mm-hmm.
And the inverse would be, f of x equals 1 over 2x.
Say it again. Say it one more time.
That's 2x.
Uh-huh.
Inverse of x. 2x would be f of x equals, 1 over 2x.
Yes. Yeah.
Yeah.
Mhm. Or 1/2 x actually.
Yeah,
Yeah.
by itself.
Yeah. Right. Mm-hmm. Let's look at an example real quick. Because I know. I know. But do you get the examples? Really? Mm-hmm. I got you. All right. So
Don't know, all you need is inverse of
but low key though, right? If you really like listen to it, you know I said the same thing just 3 times, right? I'm just repeating myself a lot. Yeah. Yeah. Like I'm not like saying like new information. It's the same information. All right, let me say it again. Same information. All right, let me say it again. Same, you know? But all right, let's look at the example. So it says identify an inverse function for a given input-output pair. If for a particular one-to-one function, f of 2 equals 4 and f of 5 equals 12, what are the corresponding output and, the corresponding input and output values for the inverse function? All right. So let's think of it like this, right? I have f of 2 is equal to 4. I have f of 5 is equal to 12, right? If I put this in a chart just to make it a little bit easier, say I call this X, I'll call this Y, right? What's X, what's Y? Tell me. Okay, X is 2 and Y is 4, okay? And X is what? 5, Y is perfect. All right. So now I want the inverse, right? So F inverse of X. So what do we think the inverse is going to be? All right, tell me. Uh-huh. Okay. That's 100% right. You're done. All right. I thought you ain't understand the paragraph though. Yeah. But it's what the word said though. All right, let's try some more. Let's try some more. Oh, hold up, I clicked the wrong thing. Oh yeah, go ahead, copy it. Go ahead. I'm sorry. Hey, how are you? Good?
Yeah.
All right. Actually, before we move on though, I just want to make a little special note. Second. All right. So notice that we show the coordinate pairs in the table form, right? The input and output are clearly reversed. Right? That's all we do. So we had an input of 2, which get output 4, and we had an input of 5, which outputted 12. To find the inverses, we swap them, right? So for the g of x, it became 4 and 2, swapped. And then for the g of x for the second point, just swapped it around, became 12 and 5. That's an inverse. X becomes y and y becomes x. Questions on that? All right. I'm gonna just be saying the same thing again. Y'all gonna hear the same story said in a different way. Mhm. Mhm. Right. The g of x is the f inverse of x. Yeah. Thank you.
Is the product of.
It's the g of x is the inverse of f of x. Yeah. Yeah. Yeah.
G of S is
The inverse of f of x. Yeah. Yeah.
always.
In this story, it is. In this lesson, it is. Yeah.
Say, shut
Yeah.
Oh, after the story.
Yeah.
But we go back, we go
Yeah.
back to the moving,
Mhm.
we go back to the real composition.
Yeah.
Function.
Mhm.
Basically, G of X is just another function. It could be because they're same thing as f of X, or is it the product of once you perform the function of other values?
It depends on the question.
That's the question.
Yeah.
Okay.
Yeah.
See how you see, my G of X, anytime I see G of X means something has changed. That's how I
Not necessarily. It depends. Depends. Sometimes g of x is just a second function that's there, and then you have to do something with it. Sometimes it is something that changed. It depends on the question. You know? All right, since we didn't understand the reading, right? Help me do this question. So given that h inverse of 6 is equal to 2, what is the corresponding input and output value of the original function? It's an inverse. It's not -1 power. So h inverse of 6 is equal to 2. So tell me what to write. I want the original function. I want like what is h of x. So yeah, h of 2 equals what? Wow. Done. I'm impressed. I'm not gonna lie. All right. Questions on that? Or was that like too quick?
Yeah. It's like, why equals X, and X equals Y.
Exactly. All right.
But when you start.
So-
Like, what do I have?
Yeah. Oh, no, we ain't get that far yet. Yeah.
You took
But it's still light though. It's still light though. Yeah.
It sounds like input equals this output, so this output equals.
Exactly. That's it. That's it. Yeah. 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 Just follow the instructions.
Like I just, I kind of did it, but I do it without. Like, but even if I, so the H, and the negative one is interesting, but sometimes they use a whole other variable to say, it's like.
Right. Just another name. Yeah. All right.
I mean, that's why you can think of like 1,000 notes.
Yeah. I feel you. I feel you. Now I know I know everybody is not like me, where like they could just be told how to do it and that's it. Some people need to see step by step how to do it. I got y'all. All right. So here you go. This step by step how to do this. Right here. Yeah, I know I was gonna give you the T. All right. So given two functions, f of x and g of x, you want to test whether the functions are inverse of each other. This is how you do it. Determine whether f of g of x is equal to x or g of f of x is equal to x. Excuse me. If both statements are true, then g is equal to f inverse and f is equal to g inverse. If either statement is false, then both are false. So g does not equal f inverse and f does not equal g inverse. All right? Good? All right.
We're gonna need a simple 1 + 2 problem to break that down.
I got you. So here's what this means, right? So we're going to be testing inverse relationships algebraically, right? If f of x is equal to 1 over x plus 2 and g of x is equal to 1 over x minus 2, right? Is g an inverse of f inverse, right? Blah, blah, blah. What am I looking for, right? I want to know if f of g of x equals x. That's all I want to know, right? So let me take f of x, right? F of x is what? It's 1 over the x plus 2. But instead of the x, what am I going to write in there? I'm going to write in the g of x, right? Which is 1 over x minus 2, right? Let's do the math on that real quick, all right? So this becomes 1 over x. I write x again. Minus 2 plus 2. Does that equal x? I don't know. Somebody help me out. What's 2 minus 2 again? 0. Appreciate that. Appreciate that. And I ain't bringing my calculator today, so kind of tough today, right? How I simplify this again? I got a fraction divided by a fraction.
1 divided by x over 1.
Good, good, right? So keep change flip, right? 1 over 1 times x over 1, right? And I want to know, does that equal x? And in fact, that's supposed to be an x, by the way. Hold on. I can't write. All right. And in fact, x does equal x. So yes, it's an inverse. All right. Go ahead. Why? Oh, because I just copied the formula right here. See that? You see it highlighted? F of g of x equals x. Right? All I have to do is prove that when I plug in one function into the other, it equals x. You know? It's all on the sheet. Yeah.
It does, this would be cool. That's kind of what we were doing before, though, no?
Yeah.
It's like, okay, it's G of X, how do we know that
They're inverses. Yeah.
So I take G of X, which only affects the X.
Mhm.
with the X's, I input this equation or this, whatever it is.
Right,
And then solve it.
exactly.
And I'll come to the same answer.
Then you're good to go. Yeah.
Same.
But just to prove that though, I'm gonna do it in reverse. I'm gonna do it in reverse also, right? Matter of fact, I'm gonna do it in blue just so we can see the reverse. All right. So what's the reverse? G of f of x, right? Does that equal x? I don't know, right? Let's try it out, right? So I'm gonna take the g of x. What's my g of x? 1 over x minus 2. And I want to know, does that equal x? I don't know. I'm going to plug in my f of x. F of x is 1 over x plus 2. Right?
Yeah.
So then now what we going to do? Keep change flip. So you already know this is 1 over 1 times x plus 2 over 1 minus 2. Does that equal x? I don't know. Right? Multiply this out. This becomes what? X plus 2 minus 2. Does that equal x? And in fact, x equals x. So it works. Right? So yes, it's an inverse. All right. That's it. Okay. I'm happy. Yeah.
Yes, but, okay. It's literally the same. We will forward, whereas we would try to move. Take it forward.
Did we do it before?
Yeah, we did.
Oh, when?
What is?
We did combinations, sorry. We did compositions. Yeah, but we weren't proving nothing. We were just doing composition.
We started, flipping,
Yeah,
switching.
yeah.
I would do the inverse of that and give you the same thing, so I know that these two
Or inverse. Yeah, right.
it's kind of what we're doing here.
Yeah. Mhm. Go down this way? Or the other way? The other way? You're welcome. Sometimes you get two, sometimes you get one. You'll see in the homework, some questions is like, here's f of x, give me f inverse. Other questions is like, all right, here's f of x, here's g of x, are they inverses of each other? You know? You're welcome. Before we move on, just want to make a little special note real quick. All right, so I want to notice that the inverse operations are in reverse order of the operations from the original function. All right, just wanted to say that. They're reversed. So you see like how I was able to do from f, no, excuse me, f composed with g of x, and I did g of x composed with f of x. That's what it means. Mhm. Let's try another one. All right. So if f of x is equal to x cubed minus 4, and g of x is equal to the cube root of x plus 4, is g f inverse. All right. Literally do the same thing. Y'all want to try it and then I do it? All right. So f of g of x equals x. The noise canceling in here is great because I can't hear no winds, no nothing. That's why I keep looking out the window like, is it still going on? It stopped? Yeah. I'm just saying I can't hear nothing. Yeah. Last summer, I remember, what did they do? Something called a welcome back party type of thing. Like, so it's literally a party on campus to welcome you back for the fall semester kind of thing. But they just happen to do it while I have class going on. So we in here suffering, everybody outside like bumping the music and eating and stuff. Yeah. Man, cotton candy and basketball and all that. The Halloween parties are the bomb.
This is bomb and come
Yeah. Yeah. Yeah, man. Yo, greatest Halloween party, man. I loved over here. You know? Yeah, yeah. Mhm. Right? Yeah. You know what really messed it up was COVID. You know, like how can I say this now? When COVID hit, everybody went home, right? So the new people that came on campus, like they never experienced the Halloween party the way it used to be. So they didn't know how to replicate that, you know? Like that's the real issue. Right. So that's what really messed it up. Yeah. City College got a nice one too, though. Like this a little different though, because they have like fraternities that do it, so it's more Greeky. Yeah. All right, all right. Which one you did? You did f of g of x or g of x of f of x? Which one you did? All right. So let's say that you had f of g of x, right? And you want to know, does that equal x, right? So what does that mean? I'm going to take f of x and I'm going to plug in g of x for the x in f of x, right? So f of x is x cubed minus 4, right? And I want to know if this equals x. I'm going to take the g of x and plug that in. So this is the cube root of x plus 4, right? So cube root and cube cancel out, right? So now I got x plus 4 minus 4, and I want to know, does that equal x, right? And in fact, it does. X equals x. And that's it. Your inverses, right? You could also do the reverse if you feel like that's easier, no pressure. You could have done g of f of x, and you want to know, right? Does that equal x? I don't know. So we take the g of x, right? Which is the cube root of, instead of the x, I'm put parentheses plus 4. And I want to know, does that equal x? Let's plug in the f of x, right? So this becomes x cubed minus 4, right? Let's drop the parentheses. This becomes a cube root of x cubed minus 4 plus 4. And I want to know, does that equal x, right? Well, the minus 4 plus 4 is going to cancel out, leaving back just the cube root of x cubed. And I'm not sure, but does that equal x? And in fact, x equals x. So yes. Mhm. Questions on that? Literally just copy and paste.
I'm going back with my question.
Thank you.
About any question.
Yeah.
Yeah.
Yeah. Cause most of the homework is like repetitive. Like once you get how to do it, it's just doing the same thing again, again, you know? And use the formula sheet, like even though I'm low key, I'm talking about the formula sheet in class, but I'm not like pointing to you where it is on the formula sheet. But like I'm explaining it. Like every time you see a formula go up in here, like that's what's on the formula sheet, you know? Mhm. Yeah. Not the other one, not the web word cheat sheet, because your exam is on a web word. The algebra and the trig one, that one. Yeah. Yeah. No, in person. Yeah, yeah.
If I'm really just thinking that.
Yeah. Nah, that's what every other class is doing. They memorizing it. Yeah, yeah, yeah. So you know what the thing is though? I find that when people make their own review sheet, they repeat information. Like so whenever I do like my statistics class, right? They get a formula sheet, very, very nice formula sheet, right? And then even if you let them write on it, they're writing the same information that's on the formula sheet. Like defeats the whole purpose. Like why'd I even give you that? You know? Mm, I don't know. Yeah. But you writing something that's not on the formula sheet. So I respect that, you know? But when you copy down the same thing that's right there, I'm just like, why? You know? Mhm.
So this is curious, but in the top of students,
Say it again?
I was a student, I was a student, I being a student. Yeah.
No, no. So the cube root and the cube, they cancel out. That's why. No, because remember, cube roots is like the 1/3 power. So 1/3 power and third power, they cancel out. Yeah. Yeah. There you go. That's it. And that,
Okay, I see.
yeah.
Wait, so then you.
Right.
You would basically like.
Right. Yeah. 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 So I did it in two colors because it's like two different formulas that I'm using, right? To be honest, if you could just do it one way, you good to go. You don't gotta do it both. But for your benefit, I did both in case you thought one way over the other and stuff like that, you know? Yeah.
Yeah, that's not, if I look at what they did, that,
Yeah.
impressed, I looked at, she had about.
Yeah.
Okay, that's what
They-
I was looking at in the chart.
They both the same. They both the same. Yeah. Yeah. Yeah.
Wait, Christian.
Hmm?
It's the same problem as student waiting to do.
Yeah.
This one.
So. The game
Mhm.
with the great faster.
Mhm.
With this, movie, we show work,
This is showing work. Yeah.
and when we get show work for like this, we have to show both sides, which.
Just one is fine. Yeah. All right, let's Uh-huh. I don't know. Read it. Yeah. You'll see it in the announcements. It's there. Yeah. I give you a hint. It's not the trig one. Yeah. Yeah. We're not gonna look at the trig one for like a couple weeks. Yeah, a couple weeks. All right, let's try another one over here. Same idea, same question, right? So determine inverse relationships of power functions. If f of x is equal to x cubed, the cube function, and g of x is equal to 1/3 x, is g an inverse of is g the f inverse, excuse me. All right. Y'all want to try it?
Yeah.
Really? Prove it.
But I got school right now.
Nah, we got to do it. That's how it should work. All my friends just text me so they made it into the radiology program. I'm like, yo, congratulations. Radiology program? Yeah, yeah, yeah. They are, yeah, that makes good money. Yeah, yeah. Oh, that's big money right there, that one. Yeah. Hmm. Yeah, yeah, that's where they are at. Yeah. So while y'all doing this, so I'm on social media, right? Just scrolling. You know how they got the news feed and social media just going down, going down, going down, right? So I see this message. I don't remember who posted it. It could have been Power 105, it could have been News 12. Somebody posted it, right? So saying how Kathy Hochul, that's our governor, right, made all the community colleges free. I don't know if y'all saw that. Mhm. That's what I heard. I don't know.
I feel like they should say,
Mhm.
and I feel straight to go with that announcement. I'm here.
I mean, but if it is, it just came out like today, so they got to work logistics out. Yeah, yeah, yeah. I heard it today. Yeah, yeah, yeah. I also heard that she banning cell phones in high schools. That's a new thing.
Yeah,
Yeah, from bell to bell, no cell phone.
anybody got, student that, and I remember when they were doing that student forgiveness. And it was a constitutional state, you did that, right?
Mhm.
If that, yeah, if that got sent to Nelnet, you could get it white clean, but they have a whole lawsuit going on right now, so you can get your shit white.
That's fire.
So if you wanna remove 10K, but other than that is, if you gotta know that, you could send them a letter
Yeah.
and go on. Because
But that-
they made a mistake.
But that's why we came to schools like this. We don't got that. That's a that's a big university-ish problem.
So,
Um,
so once I left, I
yeah.
all my dad singing.
once you get your what's it called, your PE license, your signature's worth like $50,000 right there, like, yeah, you know? Yeah, professional engineering license. Yeah,
Get that and be an asset.
yeah.
I'm gonna get that at TIA. Stack that with the.
Why?
And you eventually like, either it goes medical or both anyway.
Why?
You fulfill two goals. Now you try,
That's a good option.
Yeah,
because now this is making the software.
yeah.
Now you think of the hardware as well.
So you want to do computer engineering? Okay, that's fire.
I will finish, do it as a primary, it's sort of like I took engineering, electrical engineering, but I have the forte to do that as well. So that way it's like when, either way we communicate, like electrical engineers.
You know what you could do?
And it goes, the material.
No, but you know what you could do though?
No,
But
But they do look fair, but
yeah, they do. Yeah. What you could do, right? The electrical engineers are not licensed the way that no, excuse me. Computer engineers, I meant to say, are not licensed the way electrical engineers are, right? Like they don't take the FE and the PE, right? But you can, as a computer engineer major, take the FE and the PE for electrical, you know? So you could make it your main focus, computer engineering, right? And then you just study and take the FE and the PE. So you still you have the component the courses to work in computer engineering,
Yeah.
but at the same time, like you have the licenses to do electrical, so that's fire.
so,
City has that major, computer engineering, so like half of your courses would be coding and the other half would be like circuit classes and things like that.
yeah, I took all my kids, electrical,
Yeah.
because. And computer science from Saturday. So if I had that computer.
Not computer science, computer engineering.
Yeah,
That's what I'm saying. So,
well, I wanna do that
Yeah.
tomorrow.
okay,
It's this, go medicine, can't go.
okay.
Because that's like, you know,
I would do both in undergrad, to be honest with you.
cheaper.
It is cheaper, but also like it's not hindering you. Like if anything, it's like it's building you up more. Because you get the best of both worlds. You know. But we'll talk about it in a sec. Hold on. Let's look at this one real quick. Determining inverse relationships for power functions, right? So f of x is equal to x cubed, g of x is equal to 1/3 x, right? So I want to know f of g of x, right? Does that equal x? All right. So I'm going to take my f of x, which is x cubed. I'm going to plug in my g of x, 1/3x, right? And I want to know, does that equal x, right? So when I do this out, I believe this is 27, right? X cubed, right? Does that equal x? In fact, it doesn't. No, I'm not even going to put the question mark. It doesn't, right? So no, they're not inverses. Question on this. I don't have to do the other side. Once I prove it fails for one, I'm done. All right. So let's keep it moving. Special note. So the correct inverse to the cube is, of course, the cube roots, which is equal to x to the 1/3 power. That is the 1/3 is an exponent, not a multiplier. Let's try another one. So if f of x is equal to x minus 1 cubed and g of x is equal to the cube root of x plus 1, is g f inverse? Try it out, try it out. Sorry? I didn't do it. You're probably right. I didn't do it out yet. All right. Bop, 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 bop.
It is.
It is? All right. So I want to know if F.
But then she, F inside the G was easy.
It was easy.
That's.
Let's try this one. All right. Let's see. So F of G of X, right? I want to know, does that equal X? I don't know. Let's try it out. So I'm gonna have whatever X is minus 1 cubed, and I'm gonna take and I want to know, does that equal X, right? I'm gonna take the G of X and plug that in. So cube root of X plus 1, right? Drop the parentheses. I have cube root of X plus 1 minus 1 cubed. Does that equal X? Don't know. So then we have the cube root of X cubed, right? Does that equal X? And in fact, X does equal X. So yes.
Why compare the,
I'm sorry?
why, compare the BXQ together with the one? And we did one out together with,
They were, no? Like this?
yeah.
Yeah, so just plugged it in.
See how that's plus one in the parentheses, so that way you know to raise the X to the third power and negative one to the third power, they didn't specify that with the second.
You mean like this step right here?
Yeah, see how you moved them together there, so now we know that they're together, they didn't do that here.
Mm,
So
I knew to do that because I'm taking the whole G of X and plugging it in. So that's the G of X that's in the parentheses. Yeah. So you want to do the other way? Let's see the other way. G of F of X. Does that equal X? I don't know. All right. So let's plug it in, right? So I have the cube root of whatever X wants to be plus 1. Does that equal X? I don't know. Let's plug in this one. This is X minus 1 cubed, right? So boom. Hold on 1 second. I'm good to go. Okay. These will cancel out, leaving back just X minus 1 plus 1. Does that equal X? I don't know. But in fact, X does equal X, so yes. Okay. Questions on this? You good? All right, good, good. All right, this next thing that we're gonna go into, y'all probably already figured it out, all right? But y'all know I like to repeat myself, so I'm gonna do it again. All right. So we're gonna talk about finding domain and range of inverse functions, right? So again, y'all probably realize this already, but the outputs, excuse me, of the function f are the inputs to the f inverse, right? So the range of f is also the domain of f inverse. Likewise, because the inputs of because the inputs to f are the outputs of f inverse, the domain of f is the range of f inverse. So we can visualize this situation looking at this diagram right here, right? So in the top, right, when we had y equals f of x, for example, right, the domain of f, right, which is for f of x, goes to the range, right, x to y, right? But in the inverse, right, we swap them around, right? X becomes y, y becomes x. So the domain for f inverse, right, is like the range for f, and the range for f inverse is the x. All right, same thing. So when a function has no inverse function, it is possible to create a new function where the new function on a limited domain does have an inverse function. For example, the inverse of f of x is equal to the square root of x is the f inverse of x equal to x squared. Because a square undoes a square root, but the square is only the inverse of the square root on the domain from 0 to infinity. So since that is the range of f of x for equal to the square root of x, right? So you know when you have x squared, right? All right. So for x squared, which is the parabola, right? You have a domain that's negative infinity to positive infinity, right? But for the square root of x, which is the inverse of it, right? Remember, we only have half of it, right? From the origin going up, right? We can't have the bottom because we can't take the square root of a negative number. That's illegal, right? So that's what they're saying. The for the inverse, right? The domain would be from 0 to infinity, right? But I can't swap that around with the x squared because of the what you call it, not being able to have the negative portion of it, right? So we can only do inverses for a portion of them. That's all it's saying, right? All right. Elaborate a little bit on this. All right, so we can look at this problem from the other side, right? Starting with the square toolkit quadratic function, f of x equal to x squared. If we want to construct an inverse of this function, we run into a problem because for every given output of the quadratic function, there are two corresponding inputs, except when the input is 0. For example, the output 9 from the quadratic function corresponds to the inputs 3 and -3. But an output from a function is an input to its inverse. So if its inverse input corresponds to more than one inverse input of the original function, then the inverse is not a function at all. So to put it differently, the quadratic function is not a one-to-one function. It fails the horizontal line test. Remember that, right? So it does not have an inverse function. This is key. In order for a function to have an inverse, it must be a one-to-one function, period. Right? In many cases, if a function is not one-to-one, we can still restrict the function to a part of its domain on which it is one-to-one. So for example, right, we can make a restricted version of the square function f of x equal to x squared with its domain limited to 0 to infinity, right? Which is a one-to-one function. It passes the horizontal line test, and which has an inverse, the square root function. So if f of x is equal to x minus 1 squared on the interval from 1 to infinity, then the inverse function, f inverse of x, is going to be equal to the square root of x plus 1, right? The domain of f is equal to the range of the f inverse, which is 1 to infinity. The domain of f inverse equal to the range of f is going to be equal to 0 to infinity. All right? So just saying that. But it is interesting. That stuff.
Oh,
Huh?
I'll do this all.
The same way. The exact same way. It's just that you need to realize that because it's a square and it's failing the horizontal line test, right? It's not going to be a true inverse everywhere. It's a partial inverse, depending on the domain, right? So question, right? Is it possible for a function to have more than one inverse? No, it's not, right? If two supposedly different functions, say g and h, for example, have met the definition of being inverses of another function f, then you can prove that g is equal to h. We have just seen that some functions only have inverses if we restrict the domain of the original function. In these cases, there may be more than one way to restrict the domain, leading to different inverses. However, on any one domain, the original function still has only one unique inverse. All right. Just drop in the sauce, drop in the sauce. All right. So domain and range of inverse functions. The range of a function f of x is the domain of the inverse function f inverse of x. And the domain of f of x is the range of f inverse of x. I don't know if you caught it, but I just repeated myself there. It's the same thing I've been saying. Okay. It might sound new, but it's not. Right. Let me give you a little bit of T. All right. So given a function, find the domain and range of its inverse, right? So if the function is 1-to-1, write the range of the original function as the domain of the inverse and write the domain of the original function as the range of the inverse, right? Swap x and y, same thing, right? If the domain of the original function needs to be restricted to make it 1-to-1, then this restricted domain becomes the range of the inverse function, right? That's it.
Restricted on the inverse.
So the part that you can, the part that will pass the horizontal line test, that's your restriction.
You can still go negative.
Right, right. Mhm.
Maybe can't say crazy.
Mhm.
You say, yeah, we can't flip it, but we can hide and feel like.
Like algebraically we could flip it, but fundamentally it doesn't really work. That's the issue. That's the issue. All right, let's look at this now, right? So next thing we're gonna do, we're gonna be finding inverse of functions represented by formulas, right? So sometimes we need to know an inverse function for all the elements of its domain, not just a few. If the original function is given as a formula, for example, y as a function of x, we can often find the inverse function by solving to obtain x as a function of y, right? Also, this is the fun stuff right here. All right, this is the fun stuff right here. Let me give y'all a little bit of tea before we jump into it. All right. So given a function represented by a formula, we want to find the inverse. So here's how you do it, right? First, you got to make sure that the function is a 1-to-1 function, right? Then you want to solve for x, right? Switch x and y, right? And then replace the y with f inverse of x, right? The variables may be different in different cases, but the principle is the same, right? All right. So inverting the Fahrenheit to Celsius function. Let's take a look at this. Find a formula for the inverse function that gives Fahrenheit temperatures as a function of Celsius temperatures, right? So essentially what I'm looking for, right, is I'm looking for the inverse of Celsius, right? I'm looking for the inverse of Celsius. So how do I do this, right? I'm trying to think if I want to say it like this because I don't want to confuse y'all. Nah. It might get a little confusing if I say it. Long story short, what I'm trying to do, I'm literally just trying to solve for Fahrenheit here. You know? But I'm trying to make it theoretical. That's why I'm saying it might get a little confusing. But yeah, just solve for Fahrenheit essentially, right? You're going to divide by 5/9. What you do to one side, you gotta do to the other. So now you got 9/5 Celsius is equal to the Fahrenheit minus 32. Then you just add 32. And essentially that's it. A 9/5 Celsius plus 32 degrees is equal to the Fahrenheit. And then in this case, the Fahrenheit is the inverse of the Celsius, right? I just don't want to write that because I want to confuse y'all. No, but we know what it is. Right?
I mean, in this case, seems like,
What's the temperature, right?
See is Celsius temperature. Yeah. Yeah.
See, like that, so what time?
Yeah. It's two different notices. Two different units. I meant to say. I'm sorry.
Temperature.
Right. Right. Exactly. Yeah. Mm-hmm. Yeah.
that's all that. If I give you 32 degrees Celsius,
Mhm.
plug that into the thing, to the Fahrenheit. And in order to.
Exactly.
Justify the inverse, you plug in the Fahrenheit, where it is, you base it, it's all the C.
Exactly. Yep. That's it. That's it.
They're not, this, give you an actual version. So whatever the Fahrenheit is.
They don't get this phenomenon done. They don't.
That's what I'm saying, you go on your phone right now.
Yeah, that's true. Like, see, like, even this one. And, if I had I had this one like a tape,
Mm-hmm.
X, Y, both, I'll plug in X, solve for Y. If I go on the upper side, I'll plug in Y, solve for X.
But we're trying to avoid that, what you just said, because like it's more algebra to do that. So if I find an inverse function, I could just do a different kind of input and it becomes easier. That's why. So solve for x in terms of y, given y equals 1/3 x minus 5. All right. Blah blah blah. What's the inverse? Go ahead. Good. So divide by 1/3. What you do to one side, you do to the other. So then now you got what? 3y is equal to x minus 5. Add 5. Add 5. So I have 3y plus 5 is equal to x, right? So the inverse, I'm going to call it y inverse, is equal to 3x plus 5. That's it. One y divided by 1/3. No, so I have y over 1 divided by 1/3, right? Keep change flip. So you have y over 1 times 3/1, right? And then 3y. Yeah. Or you could have just multiplied by 3 on both sides. Whatever. Questions on this? This is how you find the inverse. Yeah. Yeah. As long as you could do this, I mean, this is like 75% of your homework. Is this one question right here?
They say, give it your homework, doing it.
Web work. This weekend, y'all should definitely catch up on homework. Like, if y'all can, come current by Monday. You know? Yeah. Yeah. You didn't start yet. Okay. The homework day. Okay. All right. Yeah. Yeah. I'm not adding any homework over the weekend. Like whatever you got today, like that's it. You know? Yeah. 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 Not for the whole course, but thus far. Yeah. Yeah. Maybe less. Because you know what messes it up is the test, you know? So like on the day of a test, I can only go through like maybe like one lesson and then give you the test. So that kind of messes it up. So maybe like this week is 8, but in the future it's probably only like 7. Yeah. Yeah. It's not, no. But as a-
Yeah, go to that, honestly, go to that.
it's built into the homework. Yeah. When you go into the homework, right? There's some questions that have videos built into it. Like those videos are from Khan Academy. You just watch them and that's it. Yeah, and WebWork. Yeah. So y'all could really like be confused on question 5 and then look at question 10 with the video, watch the video, and then come back and I do question 5 going straight down. But I do encourage y'all, yo, check out that Microsoft Copilot. Keep it 100 with y'all. I'm gonna be using Microsoft Copilot to make y'all 4th exam. Keeping it 100 with y'all. All I'm gonna do is just copy and paste. I'm gonna be like, yo, give me an inverse question. Bet, copy, paste. Yeah. I mean, like that's some old school professors. I'm trying to work up and be like that, man. I'm saying every time I'm in tutoring and I make up a question, like it don't go good, man. I don't know. My imagination too crazy, man. Too crazy.
And I heard say from some basically 37% of your grade is 100. Throw me at a
So how you guys finish this? It's light, right? No lie, I love y'all, but I'm really about to go next door to this other class. They over here dancing bachata while we in here like like no lie, they really are right there. I don't know what they doing. Yo, Ray, you think that's communication? It could be. Hmm. I mean, if they teach them bachata, I want to go up in there though. Right? Yeah, great. They look happy as hell, man. You seen the class, right? What they doing over there? Oh man, I'm looking at. I can't hear it, but I'm looking at them. Yeah, they got cake and flowers in there. Yo,
Yeah, I don't know what it is, but it's definitely not like.
oh. Man, good for them. I heard a rumor that today is their last day, so that could probably be why.
Yeah, I'll be forgetting it's summertime, and then the class is structured as 4 weeks.
Yeah.
And 6 weeks.
Some classes, yeah, some is 3, some is 4, some is 5, some is 8. Yeah.
I think I'm just.
Some schools offer this in 3 weeks. I don't know how they do it. Yeah. Yeah. Man, some of the 4-year schools they do calculus in like 3 weeks. It's beast mode, yo.
That's super.
Yeah. I mean, but
Unless they do.
I feel like it's a little bit easier because calculus is like Like the whole class, Calc 1 is 4 chapters, you know? Like we doing like 8 chapters, you know?
Yeah.
So that's the difference. All right, let's take a look at this. This showing mad complicated. I'm gonna rewrite this as y. Don't do it yet? All right, all right, all right. Because it says f of x. Yeah, you probably did it right. If you could get this, you good for your homework because this is majority of your homework right here. This one question. Besides the whole multiple choice, like yes and no stuff. You like those? Yeah. Hmm. I didn't do it yet. Let's see. So I was gonna rewrite this. Let me see. I'm gonna rewrite this as y equals 2 over x minus 3 plus 4. So here's how you do this, right? Solve for x and then swap the x and the y. That's it. So I'm gonna subtract 4 over here, which you do to one side, you do to the other. So you got y minus 4 equals 2 over x minus 3, right? And then, yep, we could do that. Multiply by x minus 3. Let me see. What's a smart way to do this? I'm trying to think. You could swap them. That's the easiest way is to swap them. You know, so if we swap them, then this is like x minus 3 is equal to 2 over the y minus 4. And then you just want to add 3 over here. Yeah. I mean, if I didn't swap it, I was gonna do the same thing on both sides. I was gonna multiply by x minus 3 on both sides, and then I was gonna divide by y minus 4 on the other. And I would have came back out with the same thing, you know? But long story short, I have x equals 2 over y minus 4 plus 3. Swap them, right? So the y inverse or f inverse of x, whatever you want to call it, is going to be equal to 2 over x minus 4 plus 3. That's my answer. Right? Yeah. I got you. Yeah. Another way you could do this too, if you wanted, right? You could have done your swap from the beginning, right? So like when we had the original function, hold on one second. Yeah, we could have done that too. So when we had y equals 2 over x minus 3 plus 4, we could have just swapped it right there and said x equals 2 over y minus 3 plus 4, and then we could have just solved for y there, you know? And then we would have got the same answer too, minus 4, x minus 4 equals 2 over y minus 3. Swap them. Hold on. Trying to go down. Swap them the way we did before. This is y minus 3 is equal to 2 over x minus 4. Add 3 to both sides. And boom, we got it. Y inverse is equal to 2 over x minus 4 plus 3. Same thing. Your choice, however you want to do it. You want to swap it at the beginning, you want to swap it at the end, whatever makes more sense to you, do. Alright. Questions on this though?
Yeah, I just,
I got you. I got you. Well, you got mad questions to practice on.
yeah.
I got you. I got you. Yeah, I got you. The recordings are posted, so y'all can always go back and rewatch anything that y'all want to watch, to do help you with the homework and stuff. I'll make a special note real quick. So the domain and range of F, right, exclude the values 3 and 4 respectively, right? So F and F inverse are equal at 2 points, but not at the same function, right? As we see in the table. All right. Let's try it again. Don't overthink it. Do it the same way. Mhm. By the way, if y'all don't have calculators, I recommend y'all get calculators. All right. The two cheapest options, if you go to like Staples, they got something called the TI 36X Pro, $20. Can't go wrong with that. Yeah. Another option that we have is upstairs, right in the library. They got the TI 83 graphing calculator that you could use. Right? Nah, it's more expensive, huh? Yeah, yeah. Right. It's more expensive than the 36X Pro, but it's older. That's the issue with it. You know. So you got to be like really, really good at like typing in what you need to type in. You know. Yeah. Yeah. Right, right. That one. Yeah. Yeah. It's all right. You could do it with just these. Yeah. 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 But if you want one like right now, right? And you can't like get it like immediately because I know sometimes they be sold out and stuff like that. They got them upstairs. You could borrow them in the library, you know. So I think you could do a 1 day loan, 2 day loan. I think you could do a week, a month, you know, a semester loan, you know. Semester loan just means 3 months. That's what it means. Ending on YouTube live with it too. Damn. Okay.
Yeah, I love.
For real?
I get myself applied to the second exam.
I mean, that could be it. I didn't do it yet, so I don't know. So what you do is literally the same thing, right? Rewrite this as y equals 2 plus the square root of x minus 4. And then your choice. If you want to swap it now and then solve for y, cool. If you want to solve for x and swap at the end, your choice. No pressure there. All right. So I'm gonna just solve for x and I'm gonna swap at the end. So I'm gonna subtract 2 from over here. What you do to one side, you do to the other. So I have y minus 2 is equal to the square root, excuse me, of x minus 4. I'm going to square it to get rid of the square root. What I do to one side, I got to do to the other, right? So now what do I have? I have y minus 2 squared is equal to x minus 4. And then what I want to do after that, I'm going to add 4 here, right? But what I do to one side, I got to do to the other. So now let's look at what I have, right? Instead of x, I'm going to do my swap now. Instead of x, I have y inverse is equal to, right? Open parentheses, x minus 2 squared plus 4, right? So that's my inverse. But I got a situation with this one, right? Because we got that square root situation, right? So I can't say that this whole square term is the inverse, right? Only a portion of it, right? So coming back up here, what's the domain of this? So from 4 to
Infinity.
right. So our domain is from 4 to infinity. Because if I plug in positive 4 here, I get 0. Yeah. Basically, whatever's on the under the radical, you just set that equal to 0, right? For a radical, it could be equal to 0, but when you're dividing by a variable, you can't divide by 0, so it won't be included. That's the big difference, right? Anyway, that's the domain of the f of x, right? That means that the domain for the what you call it, the f inverse is going to be what? It's going to be the range of this, all right? So what is the range of this function? Um, not the inverse, the range, the y values. Mm, well, it starts at what?
0,
No,
2,
2.
2.
So it's 2 to infinity, all right?
Yeah, right. 2.
Right. 2 to infinity, right? So that means that this range is now going to become the domain of this. Oh, just take the whatever's under the radical, take that and equal to 0. So x minus 4 equals 0. And the solve for it, yeah. That's fine. Yeah. Well, the range is 2 to infinity. So you know that when I'm doing the square root function, right? I start at the origin 0 and it goes to infinity, right? But you see how we're adding 2 on the outside, so you know that that's going to start above. We're going to start at where y equals 2, and then we're going to go to infinity. So that's why it's at the 2. But if I didn't have that 2 plus in front, it'd have been at 0. Yeah.
So that's like, the domain is like the 4 would be like the first
Mhm.
export you'll get.
Right.
Now, if, you know what I mean, if that, like, from the 4 to the x equals 0, well, what do we have left? We have the 2.
Right.
The 2 is, beginning.
Is your y-intercept.
Yeah.
Yeah. Mhm. Oh, the inverse is this. X minus 2 squared plus 4, right? But what I'm trying to say though, right, is that I can only look at it in terms of the domain from 2 to infinity. Right? Everything else doesn't count.
Yeah, that's why,
Mhm.
well, and what's our base of y to the next power,
Yeah,
solve them. But
got
now
you.
it's y to the second,
Mhm.
plus four, that both sides.
Right. Got you, got you.
I feel,
This step up here?
Why we did this, but why and so then cancel the so forth, the form that side.
Because I wanted to solve for X. Yeah. Mhm. But yeah, interesting stuff. Real interesting. Let me make a little special note. All right. Huh? It is an inverse question. Yeah, yeah. It's just that it's a partial inverse, you know? Yeah. So the formula we found, right, for f inverse of x looks like it would be valid for all real numbers of x. However, f inverse itself must have an inverse, namely f. So we have to restrict the domain of f inverse to 2 to infinity in order to make the f inverse a one-to-one function, right? So the domain of f inverse is exactly the range of y of f, excuse me. I don't know why I said that. All right. Let's try another one.
So once we get go through like solve the equation,
Uh-huh.
and on one side or another, once we get the x
Mm-hmm.
or the y by itself, you swap their positions.
Yes.
That,
Yes. Mhm.
that makes sense.
Yeah.
So, you know, okay, I'm gonna do
Essentially, for your homework, that's all I'm asking you to do. I'm not really asking you domain and range stuff for your homework. Mm. But I do want y'all to understand it though, just in case, you never know in the future you might need it for calculus or something. Mhm. All right. What is the inverse of this function, right? F of x is equal to 2 minus the square root of x, right? So we want to state the domains for both of the functions and the inverse functions. Not bad, right? So let's wrap this up real quick so we get to a new topic, right? So I have y is equal to 2 minus the square root of x, right? So I'm going to solve for x. I'm going to subtract 2 from over here. What I do to one side, do to the other. Y minus 2 is equal to negative square root x. I'm going to divide by negative 1. What I do to one side, I got to do to the other. So now I have negative y plus 2 is equal to square root x. Then I want to square both sides, right? Because what you do to one side, you got to do to the other. So instead of me saying x, I'm going to say y equals, open parentheses, negative x plus 2 squared. I'm sorry, that should have been y inverse. I meant to say. All right. So boom, that's my inverse. Let's go back to the original question though, right? Right here. What's my domain? Two. Good. All right. So this is going to be bracket 0 to infinity, right? What's my range? Let me see. 2. Negative infinity. Yeah. Because of the minus. As x is gonna get larger, it's gonna go to negative infinity. like say x was 100, right? The square root of 100 is 10, so 2 minus 10, -8. So the range is gonna go, I'm not even writing this right. -infinity up to 2. Right? So as x is gonna increase, it's gonna get more negative, the overall function. Right? So
How big X is,
yeah,
in order to find Y, you need to subtract it.
from 2. Yeah.
So it's going down.
Yeah.
So whether it was X, like, X equals 100 minus 2 is 98. X equals 50.
No, not like that. X, the square root of 100 is 10. So 2 minus 10 is -8, right? So as x is getting larger, right? It's more negative, you know? Square root of 400 is 20. 2 minus 20 is -18. So we're just getting deep. Yeah, so that's why it's going -infinity to 2. Yeah. And again, I'm looking at the y values for range, not the x values, the y values. All right. Anyway, I found the range of that. So that means that that range is going to be my domain for my inverse, right? So the domain for the inverse is what? Somebody copy it for me. What is it?
That's it.
-infinity to 2, right? Remember, the range of the original function is going to be the domain of the inverse. Yeah. Yeah. Right? Even though we know that that's not the real domain for this particular function, right? We have to restrict it, right? Because of the original function where it's coming from. All right. So that would be it. Okay. So we good?
Yeah. Like, it makes more sense now.
Uh-huh.
Like, I was getting confused with
Yeah.
the now I see like, once X or Y is by
Mhm.
itself,
Mm-hmm.
let it be done, I see clear right there.
That's it. That's your whole homework. Go ahead. I'm sorry.
The domain we converse, so we also need to make fully converse.
No. Yeah. The instructions only ask for the domain. Yeah. But I find the range of the original function because I know that that range is the domain for the inverse. Instead of me having to say, oh, I have to find half of this domain, like that's more complicated. All right. Real quick before we go on, right? Some of y'all might have a question like this question. Let me just answer it real quick. So is there any function that is equal to its own inverse, right? Yes, that actually happens, right? So if f is equal to f inverse, then f of x is equal to x. And we can think of several functions that have this property. The identity function does, and so does the reciprocal function, because 1/1 over x is equal to x. So any function f of x equal to c minus x, where c is a constant, is also equal to its own inverse. All right? That might help you on your homework. All right? And my fault. I should have done one of these. Go ahead.
I feel that's so
F inverse. F inverse. Yeah. Yeah. Yes. Yeah. 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 All right, this next topic is going to be mad simple. Y'all probably know it all already, so I apologize in advance. All right. So we're gonna be talking about linear functions. All right. Just to recap, a linear function is a function whose graph is a line, right? Linear functions can be written in the slope-intercept form. F of x is equal to mx plus b, also known as y equals mx plus b, right? Where b is the initial or the starting value of the function when the input x is equal to 0, and m is the constant rate of change or the slope of the function, right? And the y-intercept is 0 comma b. We know about this already, right? All right, so oh, not just okay. I got more to talk about. But if you know about this, like you could literally just knock out your homework. Like I'm just gonna elaborate on this one topic right now. All right. So now we're gonna talk about representing a linear function in function notation, right? So another approach to representing linear functions is by using function notation. One example of function notation is an equation written in the form known as the slope-intercept form of a line, where x is the input value, m is the rate of change, and b is the initial value of the dependent variable. So the equation y equals mx plus b, function notation is f of x is equal to mx plus b. Cool. All right. Again, y'all probably know this already. All right. So we're going to be determining whether a linear function is increasing, decreasing, or constant, right? So the linear function we used in the two previous examples, right, increased over time, but not every linear function does. A linear function may be increasing, decreasing, or constant. For an increasing function, as with the train example, right, the output values increase as the input values increase. The graph of an increasing function has a positive slope. A line with a positive slope slants upwards from left to right, same way you read a book, right? Which you can see in figure A right here. Let me pull that down. Boom, right? For a decreasing function, the slope is negative. The output values decrease as the input values increase, right? A line with a negative slope slants downward from left to right, right? As you can see in figure B, right? If the function is constant, the output values, right, are the same as the input values, so the slope is 0. A line with a slope of 0 is horizontal, as you can see in figure C, all right? I know y'all don't see this here, but if a horizontal line has a slope of 0, right? Like, what would a vertical line have a slope as? No, like a number. Yeah. If the horizontal line is 0, what do you think the vertical line is?
Be 0 and 0 regular.
So the slanted lines, right? They could be like fractions, like they could be like half, they could be like 2, 3, 4, whatever, right? What would the vertical line be? What would that be? If horizontal is 0, what do you think this is? 1. Good. That's it. All right. Let me give y'all a little definition real quick. Y'all probably know this definition already, but just gonna reiterate it. So increasing and decreasing functions, right? So the slope determines if the function is increasing linear, is an increasing linear function, a decreasing linear function, or a constant function. If f of x equals mx plus b is an increasing function, that means that the slope m is greater than 0. If f of x equals mx plus b is a decreasing function, that means that m, the slope, is less than 0, negative, right? If f of x equals mx plus b is a constant function, right? That means that m, the slope, is 0, right? That's it. This next part, y'all got a whole lot of questions about this on the homework. So calculating and interpreting the slope, right? In the examples we have seen so far, right, we have had the slope provided for us. However, we often need to calculate the slope given input and output values. So given two values for the input x1 and x2, right, and two corresponding values for the output y1 and y2, which can be represented by the points x1, y1, and x2, y2, we can calculate the slope m as follows. So the slope m is equal to the change in the output, rise, over run, right? The change in the input, right? So that's the change in y over the change in x, or y2 minus y1 over x2 minus x1, right? We remember this, right? It's nothing new, right? Okay. So where the change in y is the vertical displacement and the change in x is the horizontal displacement, right? Note in function notation, two corresponding values for the output of y1 and y2 for the function of f, y1 equals f of x1 and y2 is equal to f of x2. So we could equivalently write that the slope m is equal to f of x2 minus f of x1 over x2 minus x1, right? Low key, we did this already, right? Nothing new here.
Which should like zero, like the initial, and that
Right,
change.
exactly.
The whole that's myself, right?
Mhm.
And X was, and X1 was 2,
Yeah.
and X2 was 4.
Mhm.
You subtract those, you know the difference for the change.
Exactly.
X2
Right.
plus 2.
But just remember, you got to be constant, right? What you do to right, whichever one you start with on the top, you got to start with on the bottom. All right. That part is really, really, really important.
I don't even be, case that one.
And so that is a formula. Y2 minus y1 over x2 minus x1.
Like, probably give it coordinates.
Yeah.
How do I take that back into y speed?
So you find the slope, and then you pick one of those points and you plug it in, and then you solve it for y equals mx plus b. Yeah. We're gonna get to that though. Get to that. So let's look at this. Figure 6, right? Indicates how the slope of a line between the points x1, y1, and x2, y2 is calculated. Recall that the slope measures the steepness. So the greater the absolute value of the slope, the steeper the line is, right? So we have 2 points. We have x1, y1 here and x2, y2, right? Our slope formula is the change in y over change in x. So we take, let's say, y2, our top point, and our y coordinate for the second point, y1, we subtract them. Then we're going to divide it by x2 over x1, minus x1, excuse me. And that's it. That's our slope. Questions on this? Right? The slope of a function is calculated by the change in y divided by the change in x. It does not matter which coordinate is used as the x2, y2, and which one is used as x1, y1, as long as each calculation is started with the elements from the same coordinate pair, right? So if you wanted to do the reverse, say you wanted to do the bottom point first and then the top point, that's fine, as long as you're consistent, right? If I start with the bottom on the top, then I got to start with the bottom on the bottom of the formula, right? That's it. Gotta be consistent. All right, little question and answer. Are the units for the slope always units for the output over units for the input? Yes. Think of the units as the change of the output values for each unit of change in the input value. For example, an example of the slope could be miles per hour or dollars per day. Notice that the units appear as a ratio of units for the output per units for the input. All right. So to calculate the slope or the rate of change of a function m can be calculated according to the following. So the slope m is equal to the change in the input rise over the change in the output run, or it's equal to change in y over change in x, which is equal to y2 minus y1 over x2 minus x1, where x1 and y1 are input values, y1 and y2 are output values. Okay, I'm sorry?
Why not data?
They are. You could, it doesn't matter which point you,
Why can't yeah,
that's not the formula. It's always y over x, changing y over changing x. Yeah.
say that?
No, you won't. You would find a reciprocal of it, right? So it's like you would find another line that's perpendicular to the line that you want. You know? Let me give you a little bit of tea real quick. All right. So given 2 points from a linear function, we want to calculate and interpret the slope, right? So step 1, you want to determine the units for output and input values. Step 2, calculate the change of output values and change of input values. Step 3, interpret the slope as a change in output values per unit of the input value. Question? We good? All right, let's keep going. Let's look at this example. So finding the slope of a linear function, right? If f of x is a linear function and we have 2 points, 3 comma -2 and 8 comma 1 are points on a line, find the slope and is this function increasing or decreasing? All right, let's check it out. What do we know? We know that our slope m is equal to the change in y over the change in x, right? Which we know is going to be y2 minus y1 over x2 minus x1, right? It doesn't matter which point you call x1, y1 and which point you call x2, y2. I'm going to just call this one x1, y1. I'm going to call this point x2, y2. If you did the opposite on your paper, it's okay. No big deal. All right. So y2, I have 1 minus -2 over x2. I have 8 minus 3. Do the math on this. This becomes 1 plus 2 over, what's that, 5? I don't know. Y'all should check me on my math. So look, I got 3 over 5, right? Let me ask you a really hard question. 3 over 5, is that positive or negative? It's positive, right? So because this is positive, right? My function is doing what? Is it increasing or decreasing? Increasing, right? That's it. That's it. Questions on this? Anybody? No inverse.
I started with two and one.
Oh, I see. So like -2 minus 1, that's fine. You would have got -3 over 3 minus 8, which is -5. Negative divided by negative is positive, so 3 over 5. We good on this?
Yeah.
All right. I'm not gonna say that this is all your homework. Some of your homework asks you for a whole line out of this. But you guys are good, huh? Mm-hmm. Yeah.
Then I thought,
Yeah.
like, here we have, zero, five, we just identify and change one, change it next.
Right.
I don't put that back into the lead function.
So you go back to y equals mx plus b. You just found m,
Yeah.
right? Just pick one of those points and plug it in for x and y, and then solve for b. And then once you have b, you have your equation, y equals m, which is this, x plus whatever the b is you just found. And that's it. No?
Are you sure?
Yeah. Oh, we come into it. We come into it. Let me build up to it. Let me build up to it. I got you. We're gonna build up to it. Yeah.
And now you identify the change, so what is the?
Yeah. It's just plugging it into the original formula. Let me make a special note real quick. As noted earlier, the order in which we write the parentheses does not matter when we compute the slope of the line, as long as the first output value or y coordinate used corresponds to the first input value or x coordinate used. All right. Let's try another one. So if f of x is a linear function and 2, 3 and 0, 4 are points on the line, find the slope, and is this function increasing or decreasing? Y'all want to try it? And then we'll go over it. All right. Let's check it out. So my slope is equal to the change in y over the change in x. In this case, I'm going to say 3 minus 4 over 2 minus 0, which gives me a -1 over 2, right? Is this increasing or decreasing? Decreasing. And that's it. Questions on this? Anybody? We good? Yeah. All right. Let's keep it moving. I want to do that. Let's answer your question. So next thing we're going to do is writing the point slope form of a linear equation. So until now, we have been using the slope intercept form of a linear equation to describe linear functions. Here, we will learn another way to write a linear function using the point slope formula. So that formula is here. It's y minus y1 equals m times x minus x1, right? The point slope formula is derived from the slope formula, right? So we have m is equal to y minus y1 over x minus x1, assuming that x, of course, does not equal x1, right? Then we multiply by x minus x1 on both sides to get m times x minus x1 is equal to y minus y1 over x minus x1 times x minus x1. These two will cancel out, leaving behind m times x minus x1 is equal to y minus x1. Then we could rearrange it to get y minus y1 is equal to m times x minus x1, right? Point slope formula. Keep in mind that the slope intercept form and the point slope formula can be used to describe the same function. We can move from one form to another using basic algebra. For example, suppose we're given an equation in the point slope form, y minus 4 is equal to negative half times x minus 6. We can convert it to the slope intercept form as shown. So y minus 4 equals negative half times x minus 6, right? Distribute the negative half. We're going to get what? Y minus 4 is equal to negative half x plus 3. Add 4 to both sides. We're going to get what? Y equals negative half x plus 7. That's our equation of a line. All right. Questions on this?
So the other formula was calculating the,
Slope.
for the,
Yeah. Mhm.
then that function, then plug that in, and then you the,
And pick one of the points to plug in. Then that's it. Yeah. So the x1 and the y1 is one of the points. Go ahead. Distribute it.
Sure, yeah.
Yeah. Yeah.
Yeah.
Yeah. Right. And negative times negative is positive, so positive 3.
change the y, change the x.
Correct. So therefore, the same line can be described in slope-intercept form as y equals negative half x plus 7. The point-slope form of a linear equation. The point-slope form of a linear equation takes on the form y minus y1 equals m times x minus x1, where m is the slope, x1 and y1 are the x and y coordinates of a specific points through which the line passes. So one of the points that they give us, right? Just plug it in and that's it. So writing the equation of a line using a point and a slope. The point slope form is particularly useful if we know one point and the slope of a line. Suppose, for example, we are told that the line has a slope of 2 and passes through the point 4, 1. We know that slope m equals 2 and that x1 equals 4 and y1 equals 1. We can substitute these values in the general point slope equation. So now we have what? Instead of y minus y1 equal to m times x minus x1, we have y minus 1 equals 2 times x minus 4. Solve for y. Distribute the 2. What do we get? We get y minus 1 is equal to 2x minus 8. Add 1 to both sides. Final answer. We get y equals 2x minus 7. And that's it. Questions on this? That's it.
we wouldn't know where to find, X1 based on us finding out.
Right. Mhm.
Like, yeah, like this one is given,
Yeah.
but was if we would look at the previous equation that we did to get out, that would be our X1.
One of those points would be X1, Y1. One of the
Yeah.
points that was given. Yeah. Mhm. And that's it.
And what if we,
If we were.
Excel to solve, Allen,
Uh-huh.
X1 minus, X2. Could we
On the
use-
bottom.
Could we use
Yeah.
either or?
Or you have X1 minus X2.
So let's say.
On the bottom?
X1 minus X2.
Okay.
Say, example, X was 2,
Yeah.
X1 was 2,
Uh-huh.
X2 is 4. That I use
Mhm.
this, like this half the equation, so that I use Y1 and X1. And also,
Mhm.
would it be acceptable if I use X2 or Y2?
So it's acceptable if you use the X2, Y2, but something is missing in what you're doing. You know, like the one of those points that's what's becoming the X1, Y1. So the X2, Y2 will be just like an X by and a Y by itself, and then you're just solving for the variable to get the equation of a line if you need that. Yeah. So both equations, y minus 1 equals 2 times x minus 4, and y equals 2x minus 7 are described here. Over here, we're gonna do writing linear equations using points and using a point and the slope. So write the point slope form of an equation of a line with slope 3 that passes through the point 6, -1, then rewrite the slope intercept form, right? So long story short, I'm given a slope, I'm given a point, right? I want the equation of the line, right? So we're gonna find our y-intercept, put it all together, and then that's it, right? Okay. So look, I have y equals mx plus b. I know that my m is equal to what? 3. X plus b. Plug in this point that we got. So y is what? -1 is equal to 3 times the x, which is 6, plus b. -1 is equal to 18 plus b. And then we want to subtract 18. -19 equals b. Right? Rewriting this, I have y is equal to 3x minus 19. And that's it. Questions on this? Sorry? Mm-hmm. Absolutely. There you go. Mhm. That's the whole process right there. You guys try. To the Y. It's there, no? -2, 2. Oh, the Y, I plugged, hold on, wrong page. I plugged it in because I'm given the point 6, -1. -1 is the Y. Yeah. About that time. Uh, right? You going to a barbecue or something?
Say what?
You going to a barbecue or something?
Right now.
Yeah,
My phone paid me a few times, so I just spread out my package to check.
yeah.
Price, and not right now.
Okay.
So,
Mhm. You know what I was thinking about doing? I was thinking about going to like a butcher, just getting like a nice like patty from them or whatever, then getting like some good quality bread from Whole Food. you know? Just put that together.
hey,
Mm-hmm.
I understand.
For my burger, like I like onions, pickles, and tomato. Yeah. But you know what my twist is though? I like really, really, really spicy cheese. And I like spicy mayo, spicy ketchup, like yeah. Well, that's the best. That's that chimney sauce right there. That's the truth right there.
It was supposed to be that, something else, and then the good burger is pretty green.
Yeah. For me though, I would need some spice in it. I need like some hot sauce in it. Yeah. 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 And you mix it. I give you another one. When you go to could be Burger King, McDonald's, whatever, right? They have like a special sauce on some of the burgers, right? So low key, that special sauce is Thousand Island. Yeah. So Thousand Island is like a seasoned version of the pink sauce. Yeah. Try it out on your burger, like a game changer. Thousand Island. Yeah. Yeah.
It's like the most French, like a little French.
Yeah. Well, not no. You're thinking of another one. So there's one called Russian. So the Russian is the French version of the Thousand Island. The Thousand Island is the pink sauce, the mayo with the ketchup, and then like a seasoning. But Russian though is the French dressing with the seasoning. Yeah. But to be honest, every time I have my salad, straight Italian. That's my that's my dressing right there. Yeah. Yeah. You like ranch? Ranch is good too. Yeah.
Times basic.
That's how I like it though. Yeah. It's a little oregano, like yeah, like my salads is basic. My burger ain't basic, but my salad is basic. Yeah. Yeah. Oh, nice. Nice. Mhm. I don't I don't know. Like I could do I yeah, I feel like with the kale, I could do a kale spinach mix. but I can't do the raw kale. I don't know. Like kale is strong for me.
No, I go for those too. Like,
Yeah.
I'm not like,
Yeah,
I'm looking at the stereo.
that's true. That's true.
I don't think it.
Yeah. You know what it is though? Like they got the lettuce and whatnot growing over here, and then you got the cow farm right here. So then the water just
Or,
come down and then that's it. You know, like yeah,
but like, it seems better to eat these things, but
yeah,
not.
yeah,
You know what I mean? If I had lettuce tomorrow, like, so you afford it, I feel lettuce.
The thing is not
Yeah.
the time that is, you don't,
yeah,
well, just think about what the plastic function. People, come back to, but sanity is a number.
But it's plastic in the seafood, you know that.
I mean, you got those vegetarians,
I heard there's a plastic island or something. It's about the size of Texas or something in the ocean. Yeah, like a stupid like size or whatever. Yeah, yeah,
Getting a fish from the fresh water.
Wasn't getting that fish.
yeah.
Like,
That's in the fresh water. All the way out by Asia's.
there's no such thing as like fresh fish. Like Chinese kind of good.
Yeah.
They, I mean,
From what I understand, like from the research I did in terms of fish, if your fish is coming from America, yay. When it comes from another country, depends on the country it's coming from, it's a question mark. You know, like Asia is like a huge question mark. You know? Yeah. Yeah.
but it's going on, it's the water.
Mhm.
It might be a farm that's going right next to the farm. You
Mhm.
got all the fully from farms.
Mhm.
It's not,
But
but
that's where you're going into.
how they eat.
Yeah. Yeah.
Farm sound. Now,
No,
You know-
something can't be farm.
You know what? Like, I think the farm salmon, like, it's not bad, but it's where was it farmed?
Yeah. Like,
That's the
I
thing.
see the documentary, like, the fish hunters for the salmon
Yeah.
has red 40 in it. So the salmon can eat that nice pink.
That's how they get it, yeah. It's true.
I didn't know this.
Farm salmon is gray. It's
Yeah,
not
they
like
have-
orange. Yeah.
They have like water lights. I didn't even know lights still live, and I see the store Seaspiracy on Netflix.
Yeah.
Crazy, like.
But keep it 100 though. You ever went to the seafood like what you call like place and looked at the farm salmon and the wild caught salmon? Like I don't know about you, but for me, like if you told me that the farm salmon was wild caught, I couldn't tell the difference. It looks so close, you know. The only way to really tell, they have a type of salmon called red sockeye salmon,
Yeah.
right? In red sockeye salmon, it's not orange, it's red. You can't fake that. You know, like that's the real wild caught right there. You know?
Like that's what I'm saying, that's saying it's, but, just like meat, like
Yeah.
cold meat is not bad. Like
Mhm.
that right thing in the package, that's preservative,
Yeah.
because, well, really, your meat is really like colorless, like, you know, when your steak starts at the ground. The brown color, like the red is a preservative, so that's not blood inside the steak.
I don't care, I'm not.
I'm not eating the red either, but I'm just saying, it's a lot of nice.
To be honest with you though, like I like the well done. I feel like the well done is not as chewy. Like it's easier to chew and eat,
Well, like,
you know? And-
yeah. I'm not trying to take it out of, that's crazy, man. But
Technically you could,
I think you gotta leave.
but I'm not saying you should. You know, yeah. Yeah. Even with seafood, technically you could, you know, without cooking it. That's what sushi is. Not saying that you should, but I'm just saying that's what sushi is, you know?
Like, the tonsils, like, 1,000 years ago, that's what they were for,
Mm.
like, digested for things. So,
I didn't know that.
That's why, like, sometimes they get infected, you don't eat like that.
Right.
So,
Yeah.
and that's what they say, oh, no matter if we move it, if this is for digested more meat.
Right. Interesting. Interesting. All right, let's take a look at this real quick. Write the point slope formula of an equation of a line with the slope of -2 that passes through the point -2 comma 2, then rewrite it in slope intercept form. All right, that's not too bad, right? So we got y equals mx plus b, right? So now we got y equals -2x plus b. Plug in these formulas right here. I'm going to have 2 is equal to -2 times -2 plus b. It's the hard part. What's -2 times 2? That's +4. Whoops. Plus b. Going to subtract 4 from over here where we do the one side, do it to the other. So I have b is equal to -2, right? Bam. Let's rewrite this equation. So now I have what? Y is equal to -2x minus 2. And I'm done. Questions on this? Anybody? Good?
You know, like this.
Yeah.
Like, so -2, that's X, that's Y.
Right.
So it says slope of 2.
Oh, I got you. You're saying like label this, right?
Yeah.
So this is like X, this is Y right here.
Yeah.
And then this is M
Yeah.
right here. I got you. Yeah. All right, I got you.
They always get the sign before it's like, look, this the base.
Right.
That's the one.
Got you.
Yeah, they said that.
Yeah. I got you, man. All right. So if we understand this, let's jump to something else. All right. Huh? Let's talk about writing the equation of a line given 2 points. So now we ain't even got the slope. So we got to find the slope first, right? So the point slope form of the equation is also useful if we know any 2 points through which a line passes. Suppose, for example, we know that a line passes through the points 0, 1, and 3, 2. We can use the coordinates of the 2 points to find the slope. So slope is equal to y2 minus y1 over x2 minus x1. So we're going to do 2 minus 1 over 3 minus 0, which is going to give us 1/3. That's our slope. Now we can use the slope that we found and the coordinates of one of the points to find the equation of the line, right? So let's use 0, 1, for example. So we have y minus y1 equals m times x minus x1. Just plug in the m, plug in those 2 points, little math, boom, 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 right? And then we get back to our answer, right? Y is equal to 1/3 x plus 1. Questions on this? I feel like we get how to do this, right? All right. Even if you do it in your own way, just give me the right answer.
I said Y and X. Breaking down this formula,
Mm-hmm.
they need to
Yeah.
have, they don't need something. They
Mm-hmm.
need Y, they need X.
Exactly.
X1 and Y1. And what we put the number system.
Exactly. So just to illustrate this, using this graph, right? These are the points that we just talked about. These are them on the graph. Right? Let's look at this example. So this is writing linear equations using 2 points. Write the point slope form of the equation of a line passing through the point 5, 1 and 8, 7, and then rewrite it in the slope intercept form. Blah, blah, blah. Find the slope, plug it in, give me the equation of the line. That's it. All right. Do y'all want to try it, or you feel like you know it and we could just run through it real quick? You want to try it? All right, go ahead, try it. Got it? Okay. Got you. I got you. I got you. Before we leave today, we should talk about the test. What day y'all thinking about? Can't be Monday. Nah, it can't be Friday.
I think about Wednesday.
So what, Wednesday is good for everybody? All right. So just to let you know though, for the test, it should be everything we did this week and whatever we do on Monday. Probably not the stuff we do on Tuesday. Mhm. Okay. All right, so let's try this out. First thing I want to do, I want to find that slope. All right. So y2 minus y1 over x2 minus x1. I'm gonna call this x1 y1. I'm gonna call this x2 y2. Right? So I'm gonna have 7 minus 1 over 8 minus 5. I'm gonna call this 6 over 3, right? Appreciate that. So then that's 2, right? Plug it into the equation. I have y equals mx plus b. Plug in the m, I have y equals 2x plus b, right? And then now I need to plug in one of the points there. Which point y'all want to use? The first one? Good. That's the one I was going to use too. Because I don't know my 8 times table, but I know my 1 times table. All right. So my x is 5. This is 2 times 5 plus b equals 1. So this is 1 equals 10 plus b. I'm going to subtract 10 from here. I do to one side, do to the other. So I have b is equal to -9. Let's rewrite this. My final answer, y is equal to 2x minus 9. And that's my answer. Questions on that, anybody? Hmm? No. 2 times 5 is 10. And then 1 minus 10 is -9. Yeah. Huh? Y'all got 8?
Oh,
Yeah. You can use the 8 and the 7 though if you want. Yeah, my timetable's not that good though. That's why, you know. Yeah.
I got
Yeah.
one was 5.
Yeah. Yeah.
Yeah, on this one, the brand, you can put pick this up.
Right?
When you man, it's wine.
Right?
That's the whole time.
Right?
That's how it was. They had time to think.
They was philosophers, man, from they was kids.
A lot of Muslims too.
Yeah.
Let's see that fire. They figured out about
Yeah. Man, what else we got here? Y'all want to see another one, or y'all feel like y'all get it? Y'all got it? All right, let's move on. Not gonna lie, this next thing is the same thing. So we're gonna be doing writing and interpreting an equation for a linear function. So now that we have written equations for linear functions in both the slope intercept and the point slope form, we can choose which method to use based on the information we are given. The information may be provided in the form of a graph, a point, or and a slope, 2 points, and so on. Here's a graph example. Blah, blah, blah. It has 2 points. Do the same thing. All right. Let's go through it. Even though y'all know exactly what's going to happen, it's the same thing. The same thing. All right. So we're not given the slope of a line, but we can choose any 2 points on the line to find the slope. Any 2 points, doesn't matter, right? Let's choose 0, 7, and 4, 4. We can use these points to calculate the slope. Slope again is change in y over change in x, y2 minus y1 over x2 minus x1. In our case, we're going to have 4 minus 7 over 4 minus 0. It's going to give us a negative 3 over 4. Cool. Then we're going to substitute that into the point slope formula. Y minus y1 equals m times x minus x1, right? Which gives us y minus 4 is equal to negative 3 over 4 times x minus 4. Do a little math. Boom, boom, boom. Solve for the equation. We come out with y equals negative 3 over 4x plus 7. Questions on that? Straightforward, right? Make sense? All right. So if we wanted to find the slope-intercept form without first writing the point slope formula, we could have recognized that the line crosses the y-axis when the output value is 7. Therefore, b is equal to 7. We now have the initial value b and the slope m so that we can substitute m and b, right, into the slope-intercept form of a line. Okay. Fun stuff. Exactly. For your y-intercept, x is 0, and then y is whatever it is. All right. All right, so we have f of x is equal to mx plus b, where m, our slope was negative 3 over 4, and b, our y-intercept was 7. Put it together, f of x is equal to negative 3 over 4x plus 7. So the function is f of x equals negative 3 over 4x plus 7, and the linear equation would be y equals negative 3 over 4x plus 7. Boom. All right, fun stuff. Y'all know I got to give y'all a little bit of T. All right, here goes a T right here. All right. So given the graph of a linear function, write an equation to represent the function. Identify 2 points on the line, any 2 points. Use the 2 points to calculate the slope. Determine where the line crosses the y-axis to identify the y-intercept by visual inspection. Substitute the slope and the y-intercept into the slope-intercept form of the line equation. That's it. All right. Let's keep it moving. All right, let's say that I have a graph, right? It's another example right here. So I want the equation of this line, right? Make that a little bit bigger. I want the equation of this line. All I'm gonna do is pick 2 points on the line and call it a day. All right. So what 2 points do you see? All right, I see that too. Right here, right? So that's that point 0, 2. What else? I heard -2 and -4. That's a good point right there. I also saw another point up here. 2 and 8. Yeah. Right? It don't matter which two you use, right? I'm gonna use the 0, 2, and the -2 and -4 just because those numbers are smaller than 8. That's it. Right? So my slope is equal to y2 minus y1 over x2 minus x1. This is going to be what? This is going to be 2 minus -4 over 0 minus -2. Little math, boom, boom, boom. I got what? 6/2, right? Is going to be equal to 3. So now I have y equals mx plus b, y equals 3x plus b, right? And I'm gonna pick one of these ones. Let's do the 0, 2, right? So when x is 0, right, y is 2, so 2 is equal to 3 times 0 plus b, right? So b is equal to 2. Rewrite this. I have y is equal to 3x plus 2. That's my answer. Questions on this? Anybody? We good? All right, let's keep it moving. Hmm? 25. Hmm? I don't even really need to say this special note because y'all picked it up, but here it is, right? So this makes sense, right? We can see from the figure below that the line crosses the y-axis at the point 0, 2, which is the y-intercept is b equals 2. There it is. We already found that. All right, we got 2 more examples, but if you get it after this and y'all want to dip, I completely understand. So, last example. So we want to write an equation for a linear function given 2 points. But check out how our 2 points are, right? So if f is a linear function with f of 3 equal to -2 and f of 8 is equal to 1, write an equation for a function in slope-intercept form, right? All right, don't be confused by this. All right. What's x, what's y? The reverse. 3 and -2, and what else? 8 and 1. That's it. You already know what to do, right? Slope m is equal to y2 minus y1 over x2 minus x1. In this case, I'm going to do -2 minus 1 over 3 minus 8. Little math, -3 over, what's that, -5? Right? So call this 3 over 5. So now we have y is equal to 3 over, wait, let me write the formula first. Hold on. Y equals mx plus b, right? Then I have y is equal to 3 over 5x plus b. Now I have to plug in one of the points. Which am I going to plug in? -2. No. Across. Yeah, 3 and -2. All right, let's do that one, right? So this is going to be -2 is equal to 3 over 5, right? Times 3 plus b. Multiply this out. I have -2 is equal to, what's that? 9 over 5 plus b. Then I'm going to subtract 9 over 5 from here. What I do to one side, I got to do to the other. 9 over 5. So now what do I have? Oh, it's supposed to be a b, by the way. Sorry about that. So now what do I have? I have b is equal to, what's that? -2 over 1 minus 9 over 5, right? Like, in order for me to subtract that, I have the same denominator, all that good stuff, right? Times 5 times 5. Call that, this is -10 minus 9 over 5. So -19 over 5, blah, blah, blah. All right, so now what's my final answer? Y equals 3 over 5x minus 19 over 5. Let me verify that. Good. That's it. Questions on this? Did I lose anybody? We good? All right. Y'all want to see another one or y'all want to call it? What'd you say? You good? You good? All right. So that's it. The next example is gonna be the same thing as this anyway. Just to be honest with you. All right. So have a good weekend, y'all. Please, please, please come current with your homework. All right. Go ahead.
But checking in for attendance for the.
I'm good. Yeah. Yeah. Does anybody want to see Microsoft Copilot before y'all leave? Or y'all good? You have it? Y'all want to see it? Oh, yeah, let me. All right. On the recording, everybody have a good night. Talk to y'all another time. Stop recording.